This video is made for Year 11 and 12 chemists, so don't be surprised if this is a little difficult, okay? So first of all, always make sure, it's mainly to help you with your SCs and to understand them and things that are going on. So make sure you always have a lag time so you can see what the initial temperature is. This is just slightly out of whack, I think, because it does actually take a little bit of heating in the materials before it actually heats up the water. The second thing to do is that makes sure that temperature is controlled and you know it's controlled. The second thing to note is that when there are little tiny bubbles, they are from nitrogen and oxygen. So you can see from the first graph that I've got here that the most significant thing is probably going to be the oxygen that comes out. And then you can see from that graph that the amount of moles of oxygen is about 0.000625 moles. So if we do the stoichiometry on that, we will get, that will be approximately 1.4 mils of oxygen. So if you look at the funny bubbles that are forming, it looks to be about a mil. And the most significant thing is after it's boiled, I boil it again. And so you can have a look when it jumps up. That you can see that this time there's none of those little funny bubbles on the second boiling. And so that shows you that those initial bubbles are actually not water vapor. Okay. The second thing to take a note of is that it's a straight line at the top, so that shows it's a pure substance. But as you can see here, this is going to be a bit of tricky editing, me jumping back and forth, but it slightly increases over time. And if you see the second time we boil it, it's jumped up even a degree or more. So you can see that what's going on is there are dissolved salts. And so as you boil it longer, the salt increases. And so it's the ion dipole interaction you can see there is grabbing onto the water molecules more and making it harder and harder to boil. So that's called boiling point elevation. Freezing point depression also occurs, so it's harder for the crystals to line up. So if you put salt on it, it requires a colder temperature to form ice as a crystal. Okay, a second thing to note is when I remove the probe, this is a little bit out of sync as well. It takes a few seconds to cool down, doesn't actually get there, and then a few seconds to heat up. So you just need to know that there are errors going on there. And actually the main reason I was going to do this boiling water one is actually not the actual boiling, but the cooling. So it rapidly cools at the start. This experiment took up 20 minutes. So I'm doing a lot of fast forwarding. So what you're going to see is it rapidly cools at the start and then it starts to curve off. And as it gets closer to room temperature, the temperature change is less. So you need to appreciate that is one of the reasons you've got a systematic error, perhaps if you're doing change of temperature or just any experiment, because they release heat. So you need to be aware that more concentrations, increasing concentrations will inevitably increase temperatures. So that's another reason why increasing temperatures as well as increasing concentrations is going to cause a larger lack of precision. Okay, so as you can see, it's not that easy. Boiling water is, there's quite a lot going on there. So it's not that easy to understand